In this video, I'm going to talk about views for SQL. So writing SQL queries and creating views from those SQL queries. And we've already learned how to do some SQL queries, right? We learned, for example, if I had a table called actors, I could select all the values, but then maybe I want it to look a little nicer. So I can use some inline functions, and I could add a bunch of where clauses if I want. I can do joins to other tables. I can do lots of complicated stuff. And what happens in the real world is applications will, and we're going to talk about supporting applications in the next video, but applications that are supported by databases, they don't want to do all of this complicated logic, for one thing. And I'll talk about some other reasons to use views too for other purposes. But if you think about, just from a high level, if you think about how complicated some of these queries can get, from what you've learned so far, we want to try to abstract that from software developers from having to do that, right? We can simplify that by creating views. And basically what a view is, so take this as an example. If I convert this SQL statement into a view, I add the create view and then give the view a name. And then after the as clause, I put my select statement. So really all I have to do is, after I write my select statement, I put a create view on the top. Now the thing about when you create a view is you have to alias all the column names. Every column has to have a name. It can't be just blank, right? So because what we're doing is we're telling the database, when somebody does a select statement from the view name, it's going to treat it as if it were a table. But in the background, it's going and running that SQL query that was used to create that view. So when I create that view, it's sort of like I have, as far as my applications are concerned and users, it looks to them like they're querying a table, right? It's treated exactly like a table with a few minor differences, except that table is dynamically created every time you run that query. That's sort of what it seems like, right? So that's basically how this works, a view. So lots of interesting things you can do with views. It's really important to understand them if you're working with databases. To create a view, you can do create or replace, right? One or the other. So you can create view or you can replace a view if it already exists. So if you already have a view with that name, you have to use the replace keyword. Some database engines will let you run create or replace so that it'll create it if it's not there and it'll replace it if it is there. Some database engines you have to use conditional logic to check if it's there in your SQL code that creates the view. And we'll talk more about triggers and procedures in another course. I'm not really going to talk about that too much in this course. It is in the textbook in this unit, but we're not going to cover that in this particular course. So that's how you create a view, and then you have your as statement with your select statements. You can add the with check option, which I'll talk about, and the with read only, which I'm going to show you what that means. So let's take a look at an example. So let's say I created this view called actors, right? So I have a table called actor, but I'm going to create a view called actors. I'm just giving it a different name so that it's distinct from the other table name. And again, this will be treated just like a table. So once I create that view, there's my view, right? So the view gets created. Again, it's not storing any of this data, and that's the important distinction here. When you create a view, it's a virtual table more or less, but it's not storing any of that information. It's dynamically getting that information each time somebody does a query against that table. And believe it or not, that's actually a bit faster than running a select statement. One of the reasons for that is most database engines, when you use a view, it creates a query plan and caches the query plan. So it runs a little bit faster than if you ran that as just a regular select statement. It's sort of like giving the database engine a hint that, that here's information that people are going to constantly want from the database. Keep a cache of how to go and find that information, right? Just one of the other reasons that we might use a view. So now that I've created that view, I can select from it just as if it were a table, right? So I treat it just like it's any other table. I can add where clauses. I can join to other views and tables. I can do all the things that we talked about. I can use it in subqueries. Any way that you would use a table, you can use it, just as if it were a table. In fact, you can even insert to it, right? So if I try to insert to a view rather than the real table, it's going to work in many cases, right? So in this case, it'll add that record. And I can see it when I look at that view, that new record. I'll also see it in the actual underlying table. You can see here that my view doesn't have the count and the ID, so it only inserted the last name and the first name. So if one of the problems with inserting into a view is if you have a required field that's not in the view and you don't have a trigger. We haven't talked about triggers, but if you don't have a trigger that automatically inserts values that are needed, then that insert will fail on the view. So not all inserts will work with a view. And in fact, you can actually explicitly turn this off. So I'll show you an example here. Let's say I have a view, but this is the same view we were just looking at, but here I'm only showing actors where they were in more than 70 episodes. So that's going to give me a shorter list of actors, right? Because it's only people who are in more than 70. When I run that insert statement, right, into that view, it's going to work, right? It's still going to insert the record, but I'm not going to see it in my view because it's a null value for the count, right? So I'm not going to see it in that view. However, that may not be what I want, right? I don't want people inserting records into that table because semantically this wouldn't make any sense, right? So you could add, when you create your view, the with check option, and that's going to check when somebody tries to do an insert into that view. It's going to check to make sure that it would be returned with the where clause in that view. And if that's not the case, it's not going to let you insert the record. You can also use the read-only option. The read-only option will just not allow anyone to insert records. I should also tell you that in some cases, you can create views that have joins that join multiple tables. Some cases, inserts and updates will work when you have a join on a view. Inserts and updates to those tables will work. In many cases, they will fail. If the database engine doesn't know, so some databases, we talked about MyISAM and InnoDB and the difference between these different engines in MySQL. And of course, there are other database engines that exist in the world. Some of them have referential integrity baked in, right? Some of them understand how tables are related to one another. And if you create your database in a way that the database understands the relationships and how they're enforced between different tables, then inserts and updates could work through a join on a view, in theory. However, if that information isn't there, if the database engine doesn't know how to connect those tables, then inserts will fail. It has to be explicitly understood by the database engine how tables are related in order for an insert or an update to work, or a delete for that matter, against a view. But in theory, it's possible with certain database engines. We can do more complex views. So here I have a case where I've got 3 different entities. I've got actors. Actors can be a member of a cast. The cast contains a bunch of actors. Episodes have a cast. And cast, cast can be in one or many episodes, right? So I've got this relationship between actors, cast, and episodes. So if I wanted to create a more complicated query based on this structure, this is what it might look like. I'm not going to go through the select statement here. We've already learned about this, right? We learned how to create these complicated select statements, but I don't want to have to run this complicated select statement every single time I want to get this information from my database. So instead, I create a view called actors, which is based off of this complicated select statement. So basically, this is showing me all of the actors that appeared in all of the First, it gets all the Star Trek episodes, right? Any episode that was Star Trek, it gets the number of times that actor appeared in that series, and it gets their last name and their first name, right? So it basically kind of scrapes together all this disparate information from these different tables and puts it together and creates a view out of it, right? So that's one way we can simplify. Here's another example. So here I've got a table that has the counts of the number of times these actors appeared in these various seasons, in season 1, 2, 3, and 4 of a particular television series. In this case, Star Trek, right? There was 4 series, 1969, or 67 to 69, sorry. Old TV show. So if we select the last name and the first name, and then I've got all my seasons, I'm adding them up, and I'm aliasing that as counts. So this is going to give me the total count for each one of these actors. Right? So here we see all the actors and the number of episodes that they were in based on adding all those series, right? We aggregate them and give it an alias, which is count. I can also, in some database engines, I can add where the row number is less than or equal to a value. That's how I limit the number of rows. In MySQL, that would be limit. In PostGre, it's the limit keyword, which we learned about. And also in Microsoft SQL Server, it's select top 3 instead of the where clause. So a couple different ways to do it. Sybase also uses the top keyword in the select statement if you use Sybase. And then I can order it by the count so that I'm showing it in the right order, right? So I get this kind of complicated looking query. Here I've added a subquery, right? This is an inline, sort of an inline view, right? So I take that subquery and I put it in the from clause. it'll give me the same results, right? Okay, so going back to our complicated query I showed you previously, you can also, when you create a view, right? So here we have a view which is dynamically created from a whole bunch of tables, but you can also create a materialized view which sort of freezes in place the results from that select statement so it can be used for a period of time and then it's refreshed periodically. We talked about denormalizing, right? So I'm going to talk about a couple different reasons that we use views. One is denormalizing. So denormalizing is where we basically take a very well-structured database and we unwind a little bit of that to get back some of the performance in our database, right? So we talked about that. So that was denormalization. But what you could do is you could create materialized views that periodically get the information that you need for high performance queries. So the queries won't always be accurate, right? You may have queries that are slightly behind, but that's okay, right? Because we're more interested in speed than accuracy at that point, right? So maybe it's some system that has lots of transactions happening, and we don't need to see in real time. Maybe we're trying to figure out how many hot dogs to order at a 7-Eleven, right? I don't need to know how many hot dogs are sold today. I just need to look at what's happened over the last couple of weeks when I'm running these queries, right? So it's not important that the data be accurate to the second. It's just important that it's refreshed every certain period of time, right? So we can use materialized views to increase performance of the database when we have complicated queries that are very expensive for the database engine that we just want to cache it at one time periodically so that users aren't constantly hitting the database with all these queries. Another reason I want to talk about using views is abstracting data from applications. So if you think about the database and its schema, when you create a database schema, it may change over time, right? We're going to get new information that we have to store. We have to get rid of old information. We might be changing data types. There's all kinds of things that might happen, day to day as we're managing a database. What a view lets us do is abstract all of those details from applications. So one of the best practices when developing applications is rather than doing select statements directly against tables in a database, a good DBA will only allow applications to use views in the database so that they're only able to access a view. Now, you could have a view for every single table. That's one way to do that. And then you could create additional views that sort of spoon feed data to applications so developers don't have to create these complicated SQL queries. If you think about it, application developers shouldn't have to know how to do complicated SQL queries. That's something that a DBA does, right? Or a database developer would do that type of work. Again, a DBA could do it, a developer could do it. But the bottom line is that, we may not want our applications to need to have to do that work. So that's one reason. But more importantly, as changes are made to a database, we can make our views reflect what we know the application is looking for, right? So if my application is coded to look for certain column names, I can change column names in my tables as long as I update my views so that they look at the new column name, but my applications just look at the view. So as long as the view has the same column names and the same structure, then my applications aren't going to care, right? And think about this. One of the things that we talk about with databases is that a database engine, a well-designed database and a database engine does not care about the order of the columns, right? The physical structure of the table as far as the order of the columns and the order of the rows shouldn't matter. Doesn't matter, right? But you can imagine that an application developer that expects the columns to be returned in a certain order because, maybe they just use whatever the order comes from the database engine when they do a query. They're not, they're just doing select star or something like that, right? We can code that into a view, and it's always going to have the same structure for our applications when they do a query. And we can change that structure very easily without affecting the actual data in our database. So think about that. An application developer comes along and says, hey, I need my table to have a slightly different structure or different column names, or maybe on the back end of the database, you have to constantly make changes to the schema on the back end of the database. You don't want to have to keep going back to the application developers and say, hey, you got to make a bunch of changes to your database, to your code because we make changes in our database, right? That causes a lot of, issues with integration to downstream applications from the database engine. So you can see how this abstraction with views can really help us with database management, because we're not worried so much about making these structural changes in our database or making schema changes and so forth. It doesn't matter if we have views because we're abstracting that data from our applications. So some interesting ways to use it. And also, views can help us with security. In many cases with databases, I will use views as a security layer where my applications and, for example, front-end web applications will only have access to the views with their user account. They can't access the underlying tables. They can only see the views. And then I can have triggers, I can have, stored procedures and things like that. I can layer all kinds of other things on top of that if I wanted to. We can even use stored procedures instead of views as well. We'll talk about that in another class. But again, it's that layer of abstraction that can give you those additional tools that, again, we'll talk about some of this stuff later on, but I just kind of want to give you an idea of some of the reasons that we like to use views instead of giving people access directly to tables in the database. And that's it.